There is a small globe locked by poisonous ice on the edge of the solar system that is hidden deep within the immense expanse of space. Over its rough horizon, a huge shadow obscures the stars from view and the feeble sun moves slowly across the sky. The semi-darkness that is permanently cloaked in a frozen flame wrinkled with bottomless gaps cannot be dispelled by the sun's rays here. This is Pluto, a lifeless continent made of rock and cubes shrouded in unending shadow. Let's investigate it further. Pluto is a dark, undetectable object that is located around 40°O from the Sun. This far-off astronomical object travels in a relatively extended orbit around the solar system's core, completing it every 248 Earth years. Pluto is far smaller in size than both some of our satellites, such as the Moon, and all of the planets in the solar system, according to our knowledge of its radius, which is 1,188 kilometers. In addition, accurate calculations of the celestial body's mass were made possible by observations of its appropriate velocity. It was discovered to be tiny, weighing only 13 times 10 to the power of 22 kilograms, or 18% of the mass of the Moon. It is clear that Pluto has more traits with small celestial planets like Aries, Ceres, or Sadna than it does with larger bodies. This explains why it came in first place on the list of dwarf planets in 2006. Pluto has a lengthy orbital cycle as a result of its long and elongated course. The planetoid didn't reach its orbital perihelion until 1989, when it came as close to the Sun as 2970. This gap has been growing ever since, and it will be at its maximum between the years 2000 and 113. The dwarf planet will be close to its aphelion, which is 4930 from the nucleus of our solar system, by then. Pluto is a faint and extremely far-away space object as a result. It cannot be seen from Earth with the naked eye because of this. Even photographs taken by the Hubble Space Telescope show no surface details for the dwarf planet, which only seems to be a murky brown disk. Of course, it is practically impossible to analyze the heavenly body correctly in such circumstances. In order to address this issue, the unmanned orbiting station New Horizons was launched to Pluto in 2006. It traveled far and wide for 9.5 long years. It transmitted precise photos of Jupiter as it traveled. The spacecraft finally arrived at the primary target of its mission in 2015. The station performed around 400 observations while passing Pluto, gathering data totaling more than 6 GB. Additionally, it took over a year to send this substantial amount of data to Earth. Unfortunately, the probe's trajectory prevented taking pictures of the dwarf planet's whole surface. The fact is that New Horizons circled Pluto rather than entering an orbit around it so that it may investigate other space objects first. This is because, in order to fully comprehend a celestial body's geographical features, we must first comprehend its internal structure. The widely recognized theory states that Pluto contains a large core with a diameter of roughly 1,700 kilometers, made up of a mixture of different types of water, ice, and rocks. A 300 kilometers thick ice mantle surrounds the center of it. Most likely, the mantle is home to tectonic processes, albeit little is known about them at the time. The crust, which is a mixture of crystalline gases including nitrogen, methane, and carbon monoxide, covers the mantle in turn. Some theories suggest that Pluto's core could produce enough heat to melt some of the frozen mantle. In this situation, a very saline and deadly ocean with significant amounts of dissolved ammonia should be hidden deep beneath the surface of the planet Ide. The dwarf planet's surface temperature is extremely cold, not exceeding 60 Kelvin, or 213 degrees Celsius below zero. We shall begin our excursion around Pluto at its impressive and well-detailed relief Tombaugh Regio. This enormous region is formed like a heart sketch and is situated in the planetoid's equatorial region. The area was given the nickname, the Heart, because of this similarity. With a length of 2,300 kilometers, the plane takes up nearly a quarter of the overall surface area of the celestial body. The surface of Tombaugh Regio is not even. Sputnik Planitia, a smooth and light plane with a diameter of 1,492 kilometers, may be found in its western region. This area is a sizable lowland area, as may be seen by looking at an elevation chart. Carbon monoxide, solid methane, and a thick covering of nitrogen ice are all present. Because of their light color, some portions of the plane can reflect up to 90% of the light that comes into contact with them. Additionally, there are hardly any craters, indicating that the area is geologically extremely young. The major hypothesis states that Pluto collided with a big celestial body approximately 100 million years ago, leading to the formation of Sputnik Planitia. Consequently, a sizable impact crater developed. The contents of the fictitious inner ocean from the dwarf planet were within, where they quickly froze. This is supported by a few characteristic aspects of the plane's relief. For instance, it has quite a few smooth surface sections that are between 20 and 30 kilometers in length, with hills and depressions focused on their boundaries. Convection cells, which form in any fluid heated from below, are comparable to the structure of this type. This could be interpreted as a hidden affirmation of the warm interior hypothesis for Pluto.